Hi, I'm Brendan. I'm going to talk today about some of my work, and really it's teamwork, on developing alternate client libraries, the official alternate client libraries for Kubernetes. This was actually intended to be a co-presentation with Mehdi from Google, who I work with on this particular project. Unfortunately, he couldn't be here because his plane conflicted with the talk slot. So when we submitted the talk, he actually did most of the hard work to get the talk submitted. But I get to be up on stage to talk to you today. So I don't know whether that's a fair trade or not. But many thanks to him for helping kick this off, and actually do a bunch of the work that I'm going to talk about. All right. So I wanted to start first with our goals. The real idea behind this part of the project was that as Kubernetes has gained in popularity and everything else like that, there are more and more people who want to be able to interact with the API in a specific programming language. Either this is because of familiarity or existing code, or because of integration with a larger project. Tools like Jenkins are written in Java, so having a Java client makes sense. Tools like Visual Studio Code are written in TypeScript, so having a TypeScript client makes sense. There are people who are passionate around certain communities. The Haskell community, for example, is, people really like to program in that programming language. It's nice for them to be able to do so be able to talk to Kubernetes in a language that they love. And so generally speaking, the goal is to ensure that all of these languages can successfully target Kubernetes. Now, one of the things that you realize is that, and I'm sure that all of you are aware at this point, is that Kubernetes is a very rapidly changing target. And if we were sitting down, and I don't know how many APIs there are at this point, but I'll show you the JSON file that represents all the APIs, and it's like 3 megabytes at this point, I think, something like that. So that's a lot of APIs. If we were hand carving out all of those APIs, it really wouldn't be feasible. And I think if you look at the handwritten libraries that exist out there, and there are a few of them, they cover 8 or 10 of the most popular objects, and then they stop. Whereas if you use a code generator approach, you can cover the entire API, even as the API changes. And so we'll talk a little bit about that when we talk about the goal, the approach that we took. But one of the goals is not just to have great libraries for Kubernetes in all these different languages, but actually to have libraries that cover the entire space of the API, so that we don't have to say, hey, you know what? You can't use that particular new alpha feature because we haven't bothered to write down the interface for it yet. I think that another way of saying that, though, is that we also really want people to love the libraries that we build. And one of the challenges of this whole project is that languages are very individualistic. They have very varying flavors. They have wide heterogeneity in terms of the feature sets that they have. And people who program in those languages want them to feel fluent and want them to feel idiomatic. And so we need to be able to sort of each individually or collectively become, if not experts, at least familiar enough with the languages that we're building for, that we build libraries that feel right, and that people aren't sort of chafing against as they use those libraries. So in addition to having a bunch of libraries that target Kubernetes successfully, we also want to make sure that those programming language communities also feel very natural. And this extends also into tool integration, so that in the Java world, there's a set of ways that people manage dependencies, making sure we're integrated in that via Maven and Gradle and all of these tools that exist that people expect to just work. Similar things are true with NPM in the JavaScript world, with NuGet in the C# world, and pip in the Python world. There's a bunch of these things. So it's not sufficient to just write good libraries. It's actually also a case that you have to go and learn how to actually distribute software into each of these different communities. And actually, that's been a very interesting learning for me, anyway. And then I think a third goal that was really important to us is that there's a degree of equality of experience between all of these different libraries, right? So that the kinds of functionality and the kinds of features and the kinds of things that you can do in each of these libraries is roughly identical, or at least we have some way of talking about how capable a particular client library is, as well as the fact that and this is one of the challenges actually, as I'll talk to in a little bit, ensuring that if kube control and a particular kube config work, that the library and that same kube config work. Right? So if a user can use the Go client or can use the command line tooling, and then they use the Java library, and suddenly they can't load the same config file, or it doesn't authenticate properly, that's a problem, obviously. And as we'll see, that's actually an ongoing challenge because that behavior is more or less totally unspecified, except for in the code. But before we move on to some of the challenges that we see, I wanted to give you some examples of what this looks like. And this is actually drawn from the Python library. Hopefully that's legible. And so much like anything else, any other library, you're going to import a bunch of files. And this pattern actually looks, you'll see that the code looks fairly similar. We load up our config to load in the kubeconfig file. And then we can open up a YAML file as a file descriptor. We can use the YAML library, the built-in Python YAML library, to load that into an object. We can create a client, and the clients are per API group. So you'll see there I'm creating a client for the extensions v1 beta 1 API. Once I have that client for the extensions v1 beta 1 API, I can make a call to create namespace deployment, give that body that I loaded in from YAML, give the namespace. And then once that all works, I can print out, yay, I've created a deployment. And I think that this shows you that the libraries do actually, that looks largely just like Python code that you might otherwise write. With a few weirdnesses, like the camel casing of the extensions v1 beta API and things like that. And that's one of the challenges we'll talk about in a little bit. TypeScript, very similar. Import statement to pull the library in at the top, creating of a kubeconfig object, loading the kubeconfig object, creating the API object. In this case, we're using generics to be able to parameterize and instantiate the extensions v1 beta 1 API, creating a deployment by loading in from YAML, again using not a built-in, but a YAML library that exists out there that has been integrated into the client, and that's another aspect of what we do. It's not sufficient to just build these client libraries. You actually have to build a bunch of utilities around them that people, well, you don't have to, but it's nice to build a bunch of utilities around them that people expect, so the ability to easily load code from YAML. In some languages, that's more built in. YAML's pretty native to Python. In other languages, like TypeScript, not as native. And then finally, we're going to create this deployment. And again, you'll see this is idiomatic, more idiomatic JavaScript or TypeScript, where, well, I guess it would be more idiomatic TypeScript, actually, if I was using await. But it's idiomatic JavaScript, where I'm making a call into creating a namespace object, and I'm giving some promises. I'm getting back a promise and some handlers that are called, depending on how that promise outcome comes out. But it's doing exactly the same thing. And so the Python developer can create a deployment using the Python code in the previous slide. The JavaScript developer can create a deployment using the JavaScript code here. And similarly for Java and C# and Haskell, and so on and so forth. Speaking of the cluster configuration, I think it's an interesting topic because it sort of describes some of the challenges that we had when we sat down to write this object, or write these libraries. So can anybody out there tell me what the loading order is for kubeconfig files? Like if you run kubecontrol, do you know the order in which it looks for files? Anybody? Sorry, what? Environment variables, I think, the first one. Okay. Environment variables first, that's right. Home local directory is the next one. In many cases, it looks in the cluster. It looks for some magic stuff inside the cluster. And then it finally, if all else fails, it defaults to localhost 8080. And that's actually not entirely true because on Windows, there's actually multiple different places that you might call a home directory. And so in the Go client, and totally undocumented anywhere until a customer or a user yelled at us that this kubeconfig didn't work for them. Yelled is a strong term. Filed a GitHub issue. They pointed out that actually there's this Go code that is not documented anywhere that looks in a whole bunch of other directories to try and find a kubeconfig file. And so now all of the client libraries do this. So now we actually do have parity, I think. And the reason that I say I think is because I don't have a test, right? I can write unit tests for this behavior, but I don't have any like canonical, hey, I can download a set of directories and a set of environment variables, and I can run all my libraries through it and validate that the same config was loaded in all of them. There is nowhere in the project is there specified this behavior and the corresponding sort of compatibility tests that you might expect. And it's a small point at some level, although it's kind of a crucial point because if kube control works, you would expect that your client library works, or you expect that the tool written in a different language works. And if it doesn't, people get very confused. And so it's actually a very important piece of compatibility and a very important piece of the overall user experience. And then there's this added wrinkle, which is not true of the loading from a command line tool, which is that in a programmatic environment, many people expect to be able to build their config from scratch, or be able to build their config from in-memory objects, such that if initially when we had the clients the way they were, we would have to tell people like, oh, you want to build it from in-memory? You should write it to some temporary files, set this environment variable, write this YAML from these into a temporary file, set an environment variable, and then call the load config file. Obviously, in some environments, that's just not possible. And in other environments, that's a pretty awkward, hacky thing to do. And so there's this added kind of capability that we added for these client libraries, which is the ability to sort of programmatically construct your client code. And in Java, this looks like this. Builder pattern is sort of an idiomatic pattern for Java. We can say, you know what, I want to create an API client. Via this client builder, I can set my certificate authority. In this case, I actually am using a path to a file, but I could easily just use a byte stream or anything else. I'm setting the host. Eventually, I get to build my client, right? So this is a new part of building an SDK as opposed to building a command line tool. And again, this is about providing a user experience for these libraries that is more than just the ability to call the individual functions. I mentioned as well that one of the core, so this is an example of parity, right? We want to make sure that all of these libraries have exactly the same capabilities and exactly the same experiences. To achieve that, we actually have a set of standards defined for these client libraries, starting with a bronze standard that basically describes the capabilities that we expect of a client library at the bronze standard. And this includes things like loading from a kube config file, the ability to do basic auth, using client certificates, using bearer tokens, again, inline and referenced in a file. Did you know that in your kube config file, for every certificate, for every token, it can either be inline in the YAML file, or it can be a file pointer to a file on the file system. It is also the case that that file pointer is relative to the location of the kube config file, not to the home directory of the process that's running currently. We had that bug in a couple client libraries. And again, totally unspecified anywhere, right? Like, the only way you understand the behavior is by seeing what happens when you try and use kube control or when you try and use the client libraries. And then also things like TLS. TLS is interesting because every programming language is a little bit different about how they handle custom CAs. Basic API calls like pods and everything else like that, and then finally working within the cluster environment, because when people, oftentimes these SDKs are being used to build containers that run inside the cluster. Actually, the ability to load in from the cluster environment is actually probably the most important version of that. It may be documented somewhere, but the locations of all of those certificates are, again, something that I found by digging through the code. It's possible that it's located somewhere, but I don't know where it is, if that's the case. And again, that's a lot of what we do, is taking doing splunking through the client code to find out the various places that things are defined. As you move on from bronze, we add capabilities like watch. Watch is an interesting thing because, as we'll mention, as I'm going to talk about later, we use OpenAPI and code generation to generate the code that we use. Unfortunately, there is exactly no specification for anything like watch anywhere in the world of API schemas, right? There is no equivalent to OpenAPI that exists for HTTP-based watch. I mean, we invented the watch protocol. Well, the actual JSON protocol that's used for watch is invented by the Kubernetes API server anyway, but there wasn't even something we could have adopted or something where we could generate the client libraries. So in the case of watch, and if people haven't seen watch before, watch is the ability basically to open up a hanging connection to the API server and say, please tell me about changes either to an entire collection or to a specific object. All of that code is written from scratch, right? So none of that code is code generated. As a result, it's not the most awesome code to work with because you have to do things like pass entire paths. You have to, slash APIs, slash namespaces, slash my object, ... If you get it wrong, the error messages that you get aren't particularly intuitive. And so because we can't code generate for this particular class of calls, we can't provide as great a user interface experience as we do for non-watch calls. And then at the higher end of things, exec, attach, port forward, again, not supported out of the box, again, with a protocol that's not defined anywhere, and we'll talk a little bit about that protocol in a second. Protobuffer encoding, which again has the same problems. The API server chose to use ProtocolBuffer encoding, but they did not choose to use the ProtocolBuffer service definitions, so we can't generate the client libraries for talking protocol buffer. We have to, again, hand roll all the client libraries for talking protocol buffers. And then finally, generated examples. So the state of the world here is that we have 5, is that 5? Yeah, we have 5 client libraries that are supported, 4 client libraries that are supported basically up to the gold level, except for the generated examples thing. None of them have done that for whatever reason. Actually, no, it's because it's kind of annoying to do it, and nobody's bothered. But if you're looking for a starter project, things like exec and watch work throughout Python, .NET, Java, and TypeScript, and JavaScript, obviously, because TypeScript can compile down to JavaScript. There's also a Haskell library. It is less capable. It's roughly at the silver level. Has all the basic functionality. And has the ability to do watches, but doesn't have the port forwarding and some of the more advanced functionality. I should also say, actually, I lied a little bit. None of the libraries except for the Java library support ProtocolBuffer encoding either. The Java library does support ProtocolBuffer encoding. And that's partially because of some challenges with the ProtocolBuffer compiler, and partially just because, again, it's work that people have to do. It's hand work that people have to do to make it work. OK, so I'll go on to the basic approach that we've taken to building this out. We start with an OpenAPI spec, and we'll dive into the OpenAPI spec in just a second. It goes through code generation. The code generation tool is a tool that we actually don't build. It's a tool called swagger-codegen. That is out there on in GitHub. It's run by MuleSoft, I think, Facebook now, I guess. And then on top of that generated code, we add some custom code that does the things like kubeconfig loading, does things like watch, does things like port forward, all of that stuff. Mix all of that stuff together, and you have a client library that comes out the other side. The pros of this approach are obviously we get great API coverage. We have effectively perfect API coverage because we're as long as the Swagger spec is right, we get coverage of over all of the APIs. Relatively little work to do that upgrade. We'll walk through the manual process. But it's got some major advantages in terms of the ability to keep up with the project, cover the full set of APIs. We're not good SDKs, I don't think, if we don't cover every API. We're not really doing our job if we're not covering every API that people write. I would say the cons of this approach, it's complicated, and we will have bugs that people file, and I'm going to show you an example of one that seem like they should be trivially easy to fix that, in fact, are not. The code itself can be non-idiomatic because it's machine-generated code. We can do some work to kind of dress it up, but it's hard to do that in a really good way, so there's definitely some warts. And there's a number of gaps as well in the process, and I'll step through the gaps in a little more detail in a couple slides. I want to give you a sense for what the generating code process actually looks like. So inside of a container, we download the OpenAPI spec from a particular release. We are always generating code for a particular release. We munge up that OpenAPI spec because it doesn't fit with the Swagger code generator code quite perfectly. In particular, it does some weird things with packaging of the various API groups that don't generate very idiomatic libraries when you don't do idiomatic packaging when you generate the code. So we munge that up. There's an additional amount of munging that happens to do some custom typing. So, and I'll talk about that in just a second. What I mean by custom typing. Eventually, once we've sort of massaged the OpenAPI spec into a place where we think it's ready to go, we run it through the actual code generator, which is a big, hairy, complicated, templatized Java program. It generates all of the code, and one of the interesting, again, choices that happens when you do this code generator, I probably should have mentioned it in the cons section, is the code generator has made a choice about what HTTP library it's going to use, or rather, you get to choose when you generate the code which HTTP library you choose, but you are limited by the implementations, and implementing, as you can imagine, implementing a code generator or the templates for a code generator is a non-trivial task. And so, when somebody comes along and says, hey, you know what, that HTTP library that you have, and the one that we use is from Square called OKHTTP, in Java at least, they say that HTTP library is like 5 years old and deprecated, and you say, yeah, but do you want, this is one of these examples of what is seemingly an easy bug. Why don't you just go and upgrade the HTTP library that turns into this sorry, here's the path of steps you're going to have to do in order to make that change. And then similarly, the JavaScript client only works in Node, right? You can't use it in the browser right now because the HTTP library that's underneath it is the Node HTTP library. And then finally, once all that code generator's happened, we copy the code out. Then inside the client code, that generates the code. Now we have to sort of integrate it into the project. We bring it into the client library. Each client library has its own repository on GitHub. The generator code has its own repository too. We bring it into the client library. We overwrite the existing client code, generate giant diffs that nobody ever really looks at. And then we have to update the example code because oftentimes with the alpha APIs, they've changed. And sometimes actually the code generator itself has changed. Parameters move around, or new parameters are added. Do that PR, and then once we're done with everything, push up to a repository. So I've learned a lot about how you manage packages in Maven, in NPM, in all of these different, and they're all different. And so that's another piece of the puzzle where really until we've actually pushed these things out to a place where they're consumable by our target audience, our end users, we haven't actually fixed the code, right? In most cases, people don't want to be forking from GitHub their client library and compiling it on their machine. They want to consume them from these package managers. And so we've had to figure out the right ways of managing that and managing that for a lot of different approaches. OK, so looking at the gaps in this, what are the gaps in OpenAPI? Well, one of the first bugs that was filed on the Java client is the fact that if you delete something, every once in a while somebody gets an exception. It's a parsing exception. And the reason for this is that delete in Kubernetes actually is multi-value return. Well, that's not even multi-value return. It's multi-type return. It can either return a status object, or it can return the actual object that you deleted, depending on whether the delete has completed or not. It turns out that OpenAPI, the OpenAPI spec, the 2.0 version of the OpenAPI spec, simply cannot represent this. Right? It is not in the spec that you could have. It has this concept called one-of, and one-of can be used for parameters, but it can't be used for return types. Now in OpenAPI 3, that's been changed, so you can have one-of return types, but none of the code generators really support OpenAPI 3 yet. So we're stuck in this world where every month someone files another issue on their Java client saying, hey, I tried to delete something and it threw an exception. And I say, yeah, it's duplicate, see this issue here, and this is the long spew of why it doesn't work properly. Same thing with parent types, right? So lots of these object-oriented programming languages, they would really love, so in the Go client, because it's all handwritten, people have done things like said, hey, there's a runtime object, and runtime object is a base object for every other object that exists. Metadata fields, things like that are defined on that interface. Makes it very easy to write generic code around these objects. Swagger doesn't, or OpenAPI doesn't have a way of representing, hey, there's this parent class that everybody inherits from. It does actually, again, in OpenAPI 3, but again, code generators haven't caught up. And then as I mentioned earlier, you can't represent these streaming operators, and you can't represent protocol buffers. And so the gaps in OpenAPI definitely cause problems in our end user client library facing experience. There's a lot of gaps in generated code. One of the very first things we noticed as we started to try and implement things like watch was we really needed the ability to separate prepare a request, meaning get the authentication on it, set the right headers, set the right client keys, set up the certificate authority, get it ready to go, and execute the request. Because if you want to go do a watch, you need that request object in all of these languages so that you can hang on to it and stream the data back, because the response never exits effectively. Most of the client libraries were set up with the belief that if they did an API request, it goes out, it does its execution, it terminates, and then you get a response back, right? And so we had to go and do surgery in all of these code generators to basically break those methods in half so that we could have a method that basically said, get set to call the request, but don't actually execute it. And the reason for that, of course, is like I don't want to rewrite all of the code that attaches certificates, that does all of the stuff necessary to get an HTTP request ready to go. That's why I'm using a client generator. Right? That's why I'm using CodeGen, but I needed to actually go do some refactoring in the code generator in order to enable other kinds of behaviors that I needed to implement, like port forwarding and exec and watches. Thankfully, the Swagger CodeGen folks have been incredibly friendly and easy to work with, and so those PRs have landed very quickly, and we've been able to move the libraries forward. I mentioned that they're not always idiomatic, and they're inconsistently maintained. There are lots and lots and lots of null parameters, right? So like, Swagger doesn't have a good way of representing optional parameters, or at least in some languages, like Java is a great example. Optional parameters aren't really easy to represent. And so when you use the Java client, in many cases, you're going to say, create object, this namespace, and then like null, 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 right? And again, without going and doing a whole bunch of surgery on the code generator, there's not a really good way to fix that. And so it's a kind of a lousy end user experience as a result. And then I'm going to mention, I mentioned the advanced features like watch aren't there. And then this one is a great one. Someone filed a bug on me and said, filed a bug on the Java client and said, hey, I have this v1 secret object, and I have this other secret object that two requests gave me the same secret. I did .equals on them, and they're not equal. Seems like that's a bug. And we dug into it. I dug into it. It turns out that Java array equals is pointer equals by default. So if you say array dot equals some other array, it's pointer equals. It's not value equals. So and in the secret, it's an array of bytes. The data is an array of bytes. Compares the pointers, they're not equal, returns false. Swagger-codegen actually had this bug and fixed it by using array.equals, which actually does the right thing. But then actually, and so I was like, well, I think it's fixed. And they're like, no, it's still here. And I looked at it again, and it turns out actually in a secret object, the secret object has a map from string to array of bytes. And while the swagger-codegen has fixed it for array of bytes, it hasn't fixed it for map of anything to array of bytes. And if you look at the implementation of equals in map, under the hood, deep down in the Java libraries, it just calls object.equals again, and you're back at square one, right? And so this bug continues to exist. Secrets in Java still don't equal each other. If we want to fix it, we need to go into the code generator and put a whole bunch of special casing logic in to be like, oh, I'm going to do a recursive equality, and if it's a map, and if one of the fields is an array, I'm going to use this other version of equals instead of object equals. It becomes very complicated, and you start saying, well, is it worth it, right? And those are sort of the trade-offs that we have to make around user experience, known issues, and using this code generator. And then you start thinking, like, maybe we should write our own code generator, because it'll be perfect and bug-free. But of course, that's a lot of work as well. And then finally, we also find a lot of gaps in Kubernetes itself. So many parts are underspecified or not specified, or just specified in code. I mentioned how does a kube config file loaded? What are the streaming protocols? We'll actually go over the streaming protocols in just a second. But as a nice little example of this, I actually have a bug that is still open that I'm actually going to show you how we're going to fix. I root caused it, but I haven't actually fixed it. So I'll close that up. If we go over here to the Kubernetes client Java library, is that vaguely visible to people? Should I make that bigger? How's that? All right. So we're going to go over here. There's a number. There's the v1 secret always equals false. But where is this one? Support request body and proxy methods. So this is someone, maybe they're out there today, who said, hey, you know what? I'm trying to, you've generated this method that is a post to the proxy. So the API server has this proxy endpoint, which proxies the request from the API server to a pod in the cluster. You have this, excuse me, post method. I'm trying to use it. I can't put a body in my post request. There's no ability to put a body in my post request, which kind of defeats most of the point of doing a post. And he was like, it seems like Kubernetes supports this. It should support it, but it doesn't. And if I curl it, it works, but it doesn't in this library. And we say, OK. And I said, you have no idea the rabbit hole you just walked into, which is what I say to a lot of people when they ask for fixes. So I had to debug it. So we go over here and we'll go, OK, here's the mustache file. So here's the swagger-codegen mustache file, which is the code, how the code generator happens. And if we go find post, what you can see here is this local, local var post body is equal to a body param if there's a body param, otherwise null. Right? So basically what that's saying is, if in Swagger there's a body param defined, make it equal to the body param, which is a parameter that got passed into this method. If in Swagger there was no body param defined, just make it null and there will be no body. Right? So that's a bit of a clue. We said, first of all, you had to learn mustache conditionals, which I hadn't learned until I started doing this stuff. But that's what this pound and not thing is doing. So a little more about mustache templating than I ever really wanted to know. But now we know. So now we actually have some sense for why there's an issue here. We know why where the problem is coming from. But now we need to go to the Swagger spec. And so we can go over to the Swagger spec. I should actually open that in a new tab. We can go over to the Swagger spec, and we can wait till it fully downloads, because as I mentioned, it's a little bit big. We can search for proxy. Here's the get version. If you've never looked at Swagger before, this is Swagger. So you can see here, here's the definition of the post. And that's probably not very readable, so I'll zoom in on. Oh, yeah. Sorry? I still don't know what the AV dude is. Oh, my time's just about up. Yeah. I know that. Sorry. You will see that it doesn't contain this body parameter method. And so what I'm going to have to do, and since my time is up, I won't actually go and do it. I'm going to have to go into that Swagger object, add in that body parameters field, and then go through the full code regen process, right? And so I think this gives you an idea of, in some ways, it's the old garbage in, garbage out thing. If we don't write a good Swagger doc on the first place, the client libraries suffer. And so a lot of what we've done has been debugging why the Swagger doc is incorrect in the end. That is the end of my talk, I guess. I had a little bit more. I'm always worried I'm going to run out with a new talk. But if you want to learn more, please come check out all the Kubernetes client libraries. They're under GitHub, Kubernetes-client, Java, C#, JavaScript, Python, Haskell. There's a Ruby client there that's mostly abandonware. So if you're interested in Ruby and you want to play around, come take that over. There's also a Go client library there that is also needing of assistance. And then finally, if you like Lisp, as I do, I actually hand-coded a Lisp Kubernetes client library that I would also love to have people come party with me on. So come check it out. Thank you so much. I hope you enjoyed the conference. Bye.